Hello, in this video we'll take a look at checkpoint 3.54 from section 3.9, and here they want us to look at this function x to the x, y is equal to x to the x, and use logarithmic differentiation to find a derivative. So x is a base and x is a power, so you cannot use the power rule and you can't use the exponential function rule. This is neither a power function nor an exponential function. This is x to the x. So whenever your base has an x and your exponent has an x, you're kind of forced to use logarithmic differentiation. So how's that going to work? Let's write down y is equal to x to the x, our original function. And when we're looking at this, logarithmic differentiation tells us to take the logarithm of both sides so we can take advantage of log properties. So we'll take the ln of both sides. Ln of y is equal to the ln of x to the x. And immediately the logarithmic property here that would be useful for us is to bring this power down. So this is going to be x times ln of x. So now instead of having this x to the x function involved in our differentiation, we brought that down, and so now it's just a product rule. Okay. Now at this point we'll take the derivative of both sides. So let's say this step is take the ln of both sides. Ln, let's just say ln in quotes. And then in the next step over here, we're going to do the d dx, which is to take the derivative of both sides. And in doing so, we get 1 over y times y prime, or dy dx. On the left hand side, that's a derivative, and you're taking the derivative implicitly here, as if this was an implicit function, but you know it's actually explicit because we have y by itself, but we're treating it like an implicit function. And then we want to get y prime, and so we're going to multiply later on by y on both sides, and remember that y is equal to this. All right, now let's take the derivative of the right-hand side, and that power, or the product rule I was talking about. Derivative of the first times the second, plus the first times the derivative of the second, and simplify. And so as we simplify, we're going to just write ln of x plus, and then x over x is just going to be 1. Okay. And then last step here, we're going to solve for y prime. And we'll do that by just multiplying by y on both sides. So y prime is equal to, now what you have on the right hand side already is just something that you would rewrite. But instead of multiplying this by y, we'll multiply by what y is equal to, which is x to the x. So we'll multiply this by x to the x, and that's it. So remember that when you have a function that has an x in the base and an x in the exponent, we're looking at forcing ourselves to use logarithmic differentiation so we can bring the power down. So instead of having an x in the exponent, x in the base, and x in the exponent, you'll have a product rule of something with an x and ln of something with an x, which is a lot easier than trying to find this. Okay, so I hope that helps. Good luck.